So similar to the problems in direct variation, we have a problem here. If 30 workers can complete a job in 25 days, 15 workers can complete the same job in how many days? If 30 workers can complete a job in 25 days, how many days will it require for 15 workers to complete the same job? Is the question here. In inverse variation, we have seen as the number of workers increases, the number of days will decrease. In this case, the number of workers reduces. That is, less workers, more days. This is an example of inverse variation. So how to mathematically model this question? In direct variation, we took as it is. Whereas in inverse variation, take the known quantities in the inverse form. That is 15 is to 30. Take the known quantities in the inverse form. 15 is to 30 is in proportion with, take this as it is, 25 is to x. So everything is similar to direct variation except that we take the known quantity in the same form, but with so everything is similar to direct variation such that we take the unknown quantity in the same form, but we take the known quantities in the inverse ratio. So thus we form the proportion, and this is a model for inverse variation. Now we can applying the rule of proportion. What is the rule of proportion? Product of means is equal to product of extremes. Product of means is equal to product of extremes. So 30 into 25 is equal to 15x. So x is equal to 30 into 25 by 15. 15 ones are 2s are. So x is equal to 2 into 25, that is 50 days. So what is the value for x? It is 50 days. 50 days. So it is clear. As the number of workers decreases, the number of days has increased. So this is the method for solving the problem of inverse variation. சத்தம் கேட்கும்னு நினைக்கிறேன். கேக்குதா? வைக்கலாமா? So it is given it is given 15 boys working on a project. 15 boys are able to complete a project working 9 hours per day for 16 days. 15 boys are able to complete a project working 9 hours per day, similarly for 16 days. For how many days will it require to complete the same project if we are involving 18 boys working 8 hours per day? So we need to find out how many days will it require to complete the project if we are involving 18 boys working for 8 hours a day. Now, as we said, first find out the type of variation involved. Compare the known quantities with the unknown quantity. Boys and days. As the number of boys increases, the number of days will decrease. So more boys, less days. This is in inverse variation. Now compare hours and days. As the number of hours decreases, the days will increase. If you are working for 8 hours per day, if you are working for 9 hours per day and able to complete the job in 16 days, If you are going to work only for 8 hours per day, automatically the number of days will increase. So less hours, more days. So this is an example of inverse variation. So both the sides, the problem is completely in inverse variation. So similar to the problem we have seen in direct variation, we need to mathematically model in the same way. So consider boys. As I said, in direct variation we will take the known quantities as it is, 15:18. But in inverse variation, take in the inverse form. So 18:15. Okay. Now take hours. Compare hours with the required quantity days. These two are in inverse variation. So take in inverse form, 8:9. 8:9. This 2 is in proportion with, take the unknown quantity as it is. So 16:x. 16:x. Now we can apply the rule of proportion. Product of means is equal to product of extremes. So which is the mean? This is the mean quantity. And which is the extreme quantities? Okay. So product of means, that is 15 into 9 into 16 is equal to product of extremes, 18 into 8 into x. 18 into 8 into x. Sorry. So from this you can find the value of x. X is equal to 15 into 9 into 16 by 18 into 8. 8 ones are 2 sir, 9 ones are 2 sir. So 7.5 days. So the unknown quantity value is 7.5. So 15 boys working 9 hours per day complete the complete project in 16 days. If you are going to involve 18 boys working for 8 hours per day, you will require 7.5 days, that is 7.5 days to complete the same project. Write down the given quantities, find out the variation, mathematically model, find the value of x. The power. Okay, so we have used this mathematical model to represent it in the form. From this equation you can find the value of x. So x is equal to 15 into 9 into 16 by 18 into 8. So 8 ones are 2 sir. Answer is 15 days. So the value of x is 15. So 18 boys working 8 hours per day can complete the project in 15 days. So write the data, find the variation, model mathematically, find the value of x. So we have seen problems in inverse variation and problems in direct variation. This problem involves both the variations, both direct variation and inverse variation. We will see how to solve such problems. As I said, write down the data. There are 4 data involved: workers, days, hours and length. 17 workers working for 8 hours per day build a wall of length 26 meter. Okay, so we have seen problems in direct variation and we have seen problems in inverse variation. We will see a problem in which both types of variation is involved. As I said, this is an example for such a problem. Write down the data: workers, days, hours and length. It is given that 17 workers working for 18 days, 8 hours per day for 18 days, are able to dig a tunnel of 26 meter in length. Now if you want to build if you want to dig a tunnel of 39-meter length, working 9 hours per day for 6 days, how many workers will you need? So as I said, the first step is write all the data. Second one, find the types of variation involved. Compare the known quantities with the unknown quantity worker. Now first one, days. The days has decreased, less days. As the number of days decreases, the number of workers will increase. Less days, more workers. So this is an inverse variation. Now, compare hours with workers. Hours is increasing. So more hours. If the number of hours the workers are working per day increases, you can complete the job with less number of workers. So as the number of hours increases, the number of workers will decrease. So more hours, less workers. That is inverse variation. More hours, less workers. That is inverse variation. Compare length with worker. As the length increases, if you want to dig a tunnel of greater length, you need more workers. As the length increases, more length, more workers. When one quantity increases, the other quantity also increases. So this is in direct variation. So days and workers are in inverse variation, hours and workers are in inverse variation, but length and workers are in direct variation. Now, even you can compare in the same way. So length and workers are in direct variation. Now we have found the types of variations. Next, you can mathematically represent these data in terms of proportion. First one, you can represent the length and the workers. Direct variation. So, as I said, when it is in direct variation, take it as it is in the form. 26 is to 39. So, 26 is to 39. 26 is to 39. Next we can model the days. 18 days and the workers are in inverse variation. So take it in the inverse form. That is 6 is to 18. Take it in the inverse form. Direct variation we are taking as it is, 26 is to 39. Days you can take it in the inverse form, 6 is to 18. Next, hours. It is also hours and the workers are in inverse variation. So take it in the inverse form, 9 is to 8. Now this is in proportion with unknown quantity, worker. Whatever may be the variation, either direct or inverse, take the unknown quantity as it is. So 17 is to x. So once you have modeled mathematically, it becomes very easy for you to proceed in the problem. So now it is just a solution for, it is all about finding the solution for this equation. Now we have modeled mathematically. Now you can apply the rule of proportion. Product of means is equal to product of extremes. So find, you have 39, 18, 8 in the means. So find the product of 39, 18, 8 and 17, equate with 26 into 6 into 9 into x. That is 39 into 18 into 8 into 17 is equal to 26 into 6 into 9 into x. Product of means is equal to product of extremes. Find the value of x. 39 into 18 into 8 into 17, 26 into 6 into 9. So the value of X is 68 workers. So this is 68. So you need 68 workers working 9 hours per day for 6 days to dig a tunnel of 39 meter in length. Write down the data, find the type of variation, model mathematically, apply the rule of proportion, product of means is equal to product of extremes, solve the equation, find the value of X, that will be an unknown quantity. So this is a type of problem where you come across both the types of variation, say inverse variation and direct variation. Another different type of problem that many people would encounter in any type of testing is the word problems. What do you mean by word problems? Word problems are nothing but mathematical problems expressed in a narrative form. Mathematical problems expressed in the narrative form. For example, I say 5 plus 6. 5 plus 6 is equal to 11. This is a mathematical representation or a way of saying the operation addition. 5 plus 6 is equal to 11. This is a addition operation which I am representing it mathematically. 5 plus 6 is equal to 11. But I can narrate this to form a word problem. The sum of 5 and 6 is equal to 11. The sum of 5 and 6 is equal to 11. Fine. So this is a word problem. 5 plus 6 is equal to 11 can be represented as the sum of 5 and 6 is equal to 11. So this is a word problem. Now what is your job is to, given the word problem, understand you have to read the problem, find the mathematical operation and reduce it to this form. The word sum is given, so it means that addition operation between 5 and 6 and the result is 11. So 5 plus 6 is equal to 11. So this is the basic concept for any word related problem. Read the problem, analyze what operation from the words like sum, product, difference, remainder, and find the operation, find the elements that are involved in the operation, find the result and form the mathematical way of representing it. Now sum is nothing but addition, that is plus. Difference, subtraction. That is minus. Product, multiplication. Then you can say finding the quotient is nothing but division, which is represented by the division sign. Finding the quotient is to finding the quotient or finding the remainder is a division operation. But the most common type of operations that you would encounter is sum, difference and product. The sum of 5 and 6 is equal to 11. Now what is the difference of 6 and 5? It is represented as 6 minus 5 is equal to 1. So 6 minus 5 is equal to 1 can be said in a narrative form. The difference between 6 and 5 is 1. Product. Product can be represented as say product of 2 and 3 is 6. What does this mean? 2 into 3 is equal to 6. Product of 2 and 3 is 6. 2 into 3 is equal to 6. or I can also say 3 times 2 is 6. 3 times 2 is 6. 2 is 6. Or I can say 2 times 3 is 6. So the words like product, times all represent the operation called multiplication. So 3 times 2 or 2 times 3 or the product of so and so. All this represent to multiplication. Now, as we saw, the sum of 2 and 3, it represents the addition operation. Similarly, the word like increase, sum, or increase, all represents to the operation add. Now, the sum of 2 and 3 is what? 2 plus 3 is equal to 5. Now, increase 2 by 3. What does this mean? Increase 2 by 3. It means that you need to add 2 and 3. That is increase 2 by 3. From 2 increase 3 points. That is 3, 4, 5. So once again it means the same. 2 plus 3 is equal to 5. Increase 2 by 3. Now what does this mean? Increase 2 to 3. You need to be careful between these two way of operating. Increase 2 by 3 in the sense add 3 to 2. Whereas increase 2 to 3, this means increase 2 to the next level 3. You should not add 2 plus 3. It is increasing 2 to the next level 3. So the answer is 3. If you increase 2 to 3, the answer is 3. If you increase 2 to 5, answer is 5. But if you increase 2 by 3, the answer is 2 plus 3 is equal to 5. Similarly, if it is for difference, then it is called decrease. The operation will be subtraction. In that case, the difference of 7 and 2, 7 minus 2 is equal to 5. Decrease 7 by 2. This is also 7 minus 2 is equal to 5. Decrease 7 to 2. What does this mean? Decrease 7 to 2. The answer is 2. So these are some of the important words, the narrative form of mathematical operation. The narrative of the mathematical operations. Now, what are the other narrative forms? Now say 2 power 3. So this can be represented as 2 raised to 3. 2 raised to 3 or 2 power 3. 2 power 3. So commonly in a very correct form, this can be narratively expressed as 2 raised to 3. Or another way, 5 greater than 6. 5 greater than 6. That is 5 is greater than. 5 is greater than 6. 5 is greater than 6. This can be represented as 5 greater than 6. Similarly, so 6 is greater than 5. 6 greater than 5. So 6 is greater than 5 can be represented as using this form 6 greater than 5. Or 5 is lesser than 5. 5 is lesser than 6. 5 is lesser than 6. So this is the mathematical form, this is the narrative form. Now, in some word problems, you may encounter like this: 6 greater than 2 or 6 greater than x. Now a quantity x is given, they are telling 6 greater than x. What does this mean? 6 greater than x. When 6 is greater than 5, we represent it as 6 greater than 5. But when it is given as 6 greater than x, it means that you need to add 6 to x. A value 6 greater than x, that is, you are incrementing x by 6. So x plus 6. Similarly, 6 lesser than x. X minus 6. So these are some of the narrative way, and by reading these words you must be able to formulate or model the mathematical form. Once you get the mathematical form, from there you can find the unknown quantities and solve the problem. An interesting type of problem in the word related problem, or a main type of problem that you would encounter very commonly, is the age related problems. So we'll see we'll have a short insight on into the age related problems. Age related problems will be usually in the word form, in the narrative form. You should be able to model it mathematically, then solve it. So we'll have a discussion on the age related problems later. So these are the commonly encountered narrative forms. So it is given here, this is a typical age related problem. The age of 3 boys is 25 years. So it is given as the age of 3 boys is 25 years. So this is a typical age related problem, and this is a good example for an age related problem because we will come across all the modules that we have learned: average, ratio, and the basic arithmetical operations. It is given average age of 3 boys is 25 years. We have learned average is equal to the sum of all the elements that are considered by the total number of elements. So that average of 3 boys is given as 25 years. 25 years is the average, number of elements is the 3. We need to find the total age. They are in the ratio 3:5:7. The age of the 3 boys are in the ratio 3:5:7. We have to find the youngest age. First step, it is given average age of 3 boys. So average is equal to sum by n. From this you can find S. S is equal to n into A. N here is 3 boys. Average is 25. So 75 years. So the sum of all the 3 ages of the boys is 75 years. This is found using the formula for average. Now come to the ratio. It is in the ratio 3:5:7. What is our first job? We have learned to represent it in the form of 3x, 5x, 7x. What is the other method? You can simply add 3 plus 5 plus 7. That is 8, 7, 15. So the total value is 3x plus 5x plus 7x is equal to 75. In this case, 15x is equal to 75. X is equal to 5. X is equal to 5. So what is the lowest terms in this ratio? 3. X is equal to 5. Substitute x is equal to 5 here. 3 into 5 is 15. So the youngest age will be, answer is 3x. So 3 into 5. 15 years. So the youngest boy will have the age 15 years. So using the average formula, find the total number of years. Using the rule of ratios, find the sum, equate it to 75, find the value of x, substitute in the smallest ratio element. 3 into 5 is 15 years. What will be the other ages? 5 into 5, 25. 7 into 5 is 35. So the oldest person will have 35. He will be 35 years old. Youngest person will be 15 years old. So this is a good example. You can use the principles that we have learnt in word related problems, averages, proportion, and basic arithmetics too. Okay. So here is another age related problem. It is given in 1970 Ram was 3 times as old as Anita. In 1974 Ram was twice old as Anita. In 1980 what is Anita's age? In 1970 Ram was 3 times as old as Anita, and in 1974 Ram was twice old as Anita. In 1980 what will be Anita's age? As I said, in any word related problem, look for the operational words. 3 times as old as Anita. It means we need to formulate a multiplication operation. That is, let us take the unknown value, Anita's age. We need to find the age of Anita in 1980. So let it be, you need to find the age of Anita in the year 1980. Now, let us take the age of Anita in the year 1970 as X. So let Anita's age in 1970 be X years. Fine. Because we will take the earliest year. 1970, Anita's age is X years. In 1970, Ram was 3 times as old as Anita. So, Ram's age will be 3 times as old as Anita. Anita's age is X years. 3 times X, that is 3 into X. Times, the word represents the multiplication operation. So 3 times X is nothing but 3 into X is equal to 3X years. So now you know what is the age of Anita and Ram in the year 1970. Anita's is X years, Ram is 3X years. In 1974, that is 4 years have passed. If age of Anita in 1970 is X years, what will be the age of Anita in 1974? That is after 4 years. It will be X plus 4. Fine. So in 1974, Anita's age in 1974 will be X plus 4 years. Okay. What is given in the question? In 1974, Ram was twice old as Anita. What is twice old as Anita? Once again, twice is nothing but multiplying by 2. So, if you are multiplying a value by 2, it means you are doubling it, or twice. The word twice is nothing but multiplying by 2. So, Ram was twice old as Anita. So, in 1974, Ram's age will be 2 into age of Anita in 1974. X plus 4. Put X plus 4. This is nothing but 2X plus 8. Okay. So, Ram's age will be 2X plus 8. Now, what was Ram's age in the year 1970? 3X years. So, what will be Ram's age in 1974? 3X plus 4. So, in 1974, Ram's age will be 3X plus 4. But, it is given here that Ram's age at 1974 will be 2X plus 8. So, 2X plus 8 must be equal to 3X plus 4. Equate these two values. 2X plus 8 is equal to 3X plus 4. Now we have got the final equation. From this equation you can find the value of X. Say X is equal to 4 years. Isn't it? 3X minus 2X will be X. 8 minus 4 will be 4. So X is equal to 4 years. From this equation you have found the value X. Now what is X? X is nothing but the age of Anita in 1970. So in 1970, Anita was 4 years old. What you are asked? You are asked to find Anita's age in 1980. That is after 10 years. So after 10 years in the sense X plus 10. So 4 plus 10. 14 years. So Anita's age in 1980. Anita's age in the year 1980 will be 14 years old. So this is a typical age related problem. Write down the data, find out the operational word, let the unknown quantity at the earliest year be X years, proceed it, equate, find the equation, find the value of x, but this is not your answer. Check it out with what is required, find out the final answer. So here we have another type of age related problem. It is given the product of the age of Shankar and Raj is 240. The product of the age of Shankar and Raj is 240. Product in the sense multiplication. If you are multiplying the age of Shankar and Raj, you will get 240. Twice the age of Raj is more than Shankar's age by 4 years. What is Raj's age? So now what we are asked to find the age of Mr. Raj. We are given that the product of the age of Shankar and Raj is 240. Twice the age of Raj is more than Shankar's age by 4 years. So we don't know the age of Shankar and Raj clearly. Let us keep the unknown variables. Let us name the unknown variables. Let age of Raj be 240. Sorry. So let okay. So we are asked to find the age of Mr. Raj. Product of age of Shankar and Raj is given as 240. Let us keep the unknown variable. Let Shankar's age be x years. Let Shankar's age be x years. Now product of the age of Shankar and Raj is 240. So what will be Raj's age? Raj's age will be nothing but 240 by x years. Raj's age will be 240 by x years. How? Because the product of the age of Shankar and Raj is 240. We have taken Shankar's age to be x years. So x into Raj is equal to 240. So Raj's age will be 240 by x years. Now twice the age of Raj, that is 2 into 240 by x. Twice the age of Raj. 2 into, as I said, twice in the sense multiplying by 2. So 2 into age of Raj is more than Shankar's age by 4 years. That is, this is equal to Shankar's age is x. X more than Shankar's age. What do you mean by more? That is increasing, to add. It is the value of 2 into 240 by x is more than Shankar's age by 4. So 2 into 240 by x will be equal to x plus 4. So read the problem, write the mathematical form. We took Shankar's age as x years. We found the Raj's age to be 240 by x from this equation. Twice the age of Raj. So 2 into 240 by x is equal to, it is more than Shankar's age by 4 years, x plus 4. Now form the equation. What is the equation? X square plus 4 minus 480 is equal to 0. X into x is x square plus 4. 2 into 240 is 480. Bring the 480 to this side. So x square plus 4 minus 480 is equal to 0. This is a typical quadratic equation. Solve the quadratic equation. That is x Sarita?
4x
okay. So write it mathematically. Twice the age of Raj is equal to 4 more than Shankar's age. Now write the equation. X into x is x square, x into 4 is 4x. So x square plus 4x, bring 480 to that side, minus 480 is equal to 0. So this is a quadratic equation. You can solve the quadratic equation using the formula or method of factorization. You will get x into x is x square, 24 into 20 is 480. So the sign goes like this, plus 24 and minus 20 will be minus 480. So you can do this by factorization, or you can use the formula for finding the roots of the quadratic equation. So x plus 24 into x minus 20 is equal to 0, x is equal to minus 24, x is equal to 20. Age cannot be in the negative form, so cancel out this. The answer is 20 years. So what is the age of Raj? It is 20 years. So analyze the operational word, form the mathematical form, get the answer. So x is 20, age cannot be negative, so we took this value. After solving the quadratic equation, we found that Raj's age is 20 years. So we know the traditional way of multiplying. We feel that traditional way of multiplying is simple and it is easy to do. For example, you multiply say 45 into 25. So what is the usual way of multiplying? We take the value in the unit digit, multiply this. 5 into 5 is 25, remainder 2. 5 into 4 is 20, 20 plus 2 is 22. Then you put a plus sign here, take the 2, 2 into 5 is 0, 10, take the carryover,